Hi, today we are going to take a look at this avionics box. This is the transceiver 618M1. You can see on the front panel different things. We have three jack connectors here, external meter, so this is for some self-tests here. Okay, so there is a test of power supplies, antenna, the standing wave ratio, the modulator, off. There is a jack here for the mic, for the phone. On the rear there are two connectors, and there is one coaxial connector here for the antenna. By chance I found that in my avionics junk box. It is incredible because this connector fits perfectly. Okay, so it fits perfectly. It is quite incredible to have such connector. And I have also this VHF communication device. This permits to set the frequency. It is not exactly the frequency selector which is expected to be connected to this unit, but the selector which is recommended for this unit is model 313. And we can find some of them on eBay, but for a price between 300 and 600 Yankee bucks. So it is quite incredible price for something like that. So I found this one. So I think it is compatible because there is a standard for this kind of frequency selector, which is ARINC 410. And I think that this selector is compliant with this standard. And I have also something else. This thing is a technical manual of this unit, so you can see the size of that thing. So the goal will be to do a teardown of that unit, and after that it should be interesting to test this unit. I am close to Roissy-Charles de Gaulle Airport, approximately 15 kilometers, so maybe it should be possible to receive some communications. As you can hear, there are a lot of aircraft. First, let's open this thing to see what is inside. Okay, look at that. Oops. Okay, so we can see first that there is a blower here, and we can see that one wire was desoldered. So I think that someone has tested this unit, and maybe because of the noise, the blower was disconnected. So I think it can be interesting to see the block diagram for that unit. I will test only the receiver mode, of course. We can see here the block diagram of this unit. The antenna is here. There is an RF amplifier here. And there is the first mixer. There is a VHF oscillator which gives a frequency by step of 1 MHz. There is the first IF filter of 15 MHz and a second mixer. The second mixer permits to have a frequency step of 50 kHz. There is here a high frequency oscillator which gives a frequency around 12 MHz with a step of 50 kHz. Therefore there is another IF amplifier with a frequency of 3 MHz. And there is a third mixer with an oscillator of 3.5 MHz which gives another IF of 500 kHz. The bandwidth of this amplifier is 40 kHz. There is another version of this unit which has a frequency step of 25 kHz, and in this case the bandwidth of the filter is 20 kHz. Today the frequency step is 8.33 kHz. And after that there is an AM demodulation using a classic diode. Let's start from this side. The antenna is connected here through this coaxial cable. There is an RF switch here, which permits to select between the transmitter mode and the receiver mode. The output stage of the transceiver mode is here. Okay, so there is a power vacuum tube inside. So this is the output filter. The output is connected directly to the coaxial relay here. And the receive mode is here. So this coaxial cable is connected to the RF amplifier. The RF amplifier is here. You can see this coaxial cable, which comes from the high frequency relay. Below these shields here, we have the frequency selector. So this is a very interesting electromechanical assembly. So let's remove these shields here. So we can see here the selection of the first local oscillator. There are exactly 34 crystals. So on the other side, there are 20 crystals for the second local oscillator. So there is a second mixer with a frequency around 12 MHz, which is here. The selection of all crystals are done using rotary switches. There is one here and two others on that side. The rotary switches are linked to this DC motor. We can see here a block diagram of that system. There is only one motor. The motor is linked to the VHF auto positioner seeking switches and also for the high frequency auto positioner seeking switches. Okay, the high frequency is this one, the VHF is this one. It is possible because there are actually two slip clutches. There is also a differential, we will see in one moment. The differential permits to combine the angle of these two shafts here into a single one, which permits to drive the tuning capacitors. So we can see here the bunch of tuning caps here and the differential. The tuning caps are used in most of the circuits. For example, we have here the input amplifier, okay, which is here. We can see the tuning caps, okay, which permits to tune. So here the input to the frequency, and here, for example, this transformer also. So we can see the tuning caps here, linked mechanically. Here, this is this shaft here. Okay, so we can see the differential here. One input of the differential is linked to a cam here, which is not linear. It is this lever and this cam. And there is a second input, which is this gear here. And this permits to set with accuracy the shaft of these tuning caps. On this plate is the receiver circuits. Old school wiring. Now we can see here the final stage for the transmitter. You can see the schematic diagram here. There is a driver tube, which is a 7558, which is here, this one. Okay, and there is a final tube, here the power amplifier tube, an 8121, which is inside this shield. Okay, so we can see that we have a directional coupler here, which permits to measure the standing wave ratio. I can see the detection voltage here. We have an image of the transmitting power and the reverse power also. Okay, so we can see here the power tube. So we can see here the coupling between the amplifier and the antenna. Okay, so the antenna is here, so the output. Okay, so this seems to be a decoupling capacitor. High voltage, I don't know the voltage here. Let me see. The voltage is 360 volts at that point. And we have also two tuning caps here. Okay, you can see these tuning caps here. C161. And we can see also the output filter, which is inside this box here. Okay, which is this filter here. Okay, and the output here goes to the antenna relay. So there is a direct connection. So this is the connection we can see here. We can see this coaxial connector. This is Unix, one of my cats. And this is the bottom side of this transceiver. Okay, so first we can see that we have two spare fuses here. This is the transformer for the high voltage power supply. We can see the schematic of this power supply. It is a classic auto-resonant switched mode power supply. It uses the saturation of the core here. Here we have the modulation transformer. Okay, we can see this transformer here. So there is the modulation of the plate and the modulation of the screen also. The audio signal is here. Okay, it is fed to this amplifier. There is a limiter, the modulator driver, and the modulator itself here. The secondaries of this transformer are in series with the plate here. Okay, and with the screen here. There is at the same time a plate modulation and a screen modulation. And we have here a filter assembly for the power supply. We can see here several power transistors. These two transistors in TO66 package are used for the modulator. Two others are used for the power supply, for the auto-resonant switched mode power supply for the high voltage. That's all for today. Thank you for watching and see you next time. Bye bye.